continue our 6.4, the central limit theorem. We skipped 6.3, so don't worry about it. Right? From 6.2, we find the probability and then use table A2, which is normal distribution. Now, if it's not normal distribution, you cannot use table A2. So how do we fix that problem? We're going to use central limit theorem here. So if the population is normally distributed, you don't have to worry about sample. Now, if the population distribution is unknown, you need to apply the central limit theorem, which states that for all sample of the size n and n greater than 30 of sample x bar can be approximately normal distribution with mean, mu, and standard deviation sigma over square root of n. So basically what the theorem said, if your sample size is at least 30, your sample mean will be approximately normal distribution. So let's go over some notation. Mu x bar is the mean of all value of x bar, and it's always going to equal to population mean. The sigma x bar is a standard deviation of all value of x bar and is equal to sigma over square root n. Sigma is population standard deviation, n is the sample size. Z here is your z-score. The z-score is equal to x bar minus mu x bar divided by sigma x bar. Now let's look at our example here. Assume that female have pulse rate that are normally distributed. So the population here is normally distributed with the mean of 74 beats per minute. So we know that we don't have to worry about the sample size because the population is normally distributed. So it's bell shape. Alright, it's bell shape. Now the mean in this case is the population mean is 74 beats per minute. And standard deviation in this case is population standard deviation is 12.5 beats per minute. Right? Now if 25 adult female are randomly selected, so n here is 25. It's not greater than 30, but it's okay because the population is normally distributed. Then they want to find the probability. Find the probability is mean find the area under the curve. So we can use table A2. So mu x bar is always equal to mu, which is 74. So mean go to the center. Now they want to find the probability that their pulse rate have the mean greater than 70. 74 here, 70 is to my left, right? So 70 is somewhere here. Greater than 70, so the shaded area is to the right. Shaded area to the right. This is the normal distribution curve. We have to convert it to standard normal distribution curve, which is also bell shape. 0 in the center, negative to the left, positive to the right. Alright, and I'm going to use this formula to find the z-score. Alright, I'm going to use this formula to find the z-score. So z is equal to x bar, which is 70, minus mu x bar, which is 74, divided by standard deviation, 12.5. Sample size is 25. Alright, now if I calculate this, it's gonna be negative 1.6. Negative 1.60. So negative 1, negative 1.6 is somewhere here. And they want the area to the right. Now you have to use table A2. Again, table A2 gives the shaded area to the left of the z-score. So if you look in the table A2, it will give you the area to the left is 0.0548. Alright, but we don't want the area to the left, we want area to the right. So the area will be 1 minus this. So area would be 1 minus 0.0548 because it's the area to the right. Right? If you subtract this, you should get 0.9452. If you convert to percent, is 94.52%. You move the decimal to the right 2 places. So 94.52% have the pulse rate greater than 70 beats per minute. Alright, we finished chapter 6. I'll see you later.